All right, we're now on the 4.5, and we're looking at rhombi, that's the plural of rhombus, and squares. So again, this is just a more specific parallelogram, just like we did yesterday on rectangles. Let's go ahead and write a definition. I'm actually going to use the text box. Okay. So what makes this one special today? We're going to be looking at it. So a possible response here could be, again, just like yesterday, a parallelogram with all congruent sides. And the true definition, let's put a little asterisk here, is 4 equal sides is what makes a rhombus. Looks a little better. Okay, so notice that parallelograms are the bigger circle and rhombi are the smaller circle. So now we're going to go look at some logical statements here. All rhombi are parallelograms, but only some parallelograms are rhombi. All rhombi are quadrilaterals. They all have 4 sides, but only some quadrilaterals are rhombi. Why do all of the properties of parallelograms apply to rhombi? Because rhombi are parallelograms. So here's all of the properties of parallelograms that we saw from the exposure last week. And then we now are adding what makes a rhombus specifically. So all sides are congruent is the number 1. Adjacent sides are congruent. Adjacent meaning right next to. Diagonals are perpendicular. This is new. And the diagonals bisect each other. Sorry, the diagonals bisect the interior angles. Diagonals bisect each other is already one of them from up here, but diagonals bisect each interior angle is the new one. Okay, so let's go look at a practice using this. So we've got this little X marked right here. We've got this little X plus 14 marked over here, right here, and right here. ABCD is a rhombus. Follow the steps to find the value of X. So unlike the rectangle yesterday, where we could just assume that that was an isosceles, let's see what's going on here first. If the measure of angle AED, so going back up here, AED right here, they're telling us is equal to 90. And the sum of the interior angles of a triangle is 180, we could say that those 3 angles equal 180. So X plus 14 plus that 90 equal 180, and then we solve. 2x plus 14 plus 90 would be 2x plus 104. Subtract the 104 from both sides. Leaves us 76. Divide 76 by 2. Gives us 38. So that's how we used it to solve backwards for x. Again, how could we prove that a parallelogram is a rhombus? We could show that all sides are congruent. That's the number 1. We could show that one pair of adjacent sides are congruent. So that's enough. Put a little star next to this. It's probably going to be on apex. Show that its diagonals are perpendicular to each other. And remember the symbol we use for perpendicular, like an upside down T, and it actually looks like two lines that are perpendicular to each other. I remind you of that in case they're using that notation. Show that its diagonals bisect each interior angle. So specifically, I would need to see something from this list in order to prove that it's a rhombus. A square is a rectangle with all congruent sides. And a square is a rhombus with all right angles. So we looked at general rhombi today, but a square is a very, very specific type. So here now we have the entire chart of parallelograms. Squares are the most specific. Then there's rhombis and rectangles inside. Notice that squares are the intersection of the two. And then there's the entire broad parallelograms. And then we can make some statements here based on this, such as all squares are rhombi, but only some rhombi are squares. All squares are rectangles, but only some rectangles are squares. All rhombi and squares are parallelograms, and then all rhombi and squares are quads. So let's put this all into a chart, quick reference. Which ones have these properties? All angles are right angles. Notice they checked yes on rectangle and a square. All sides are congruent. Square and rhombus have that. Consecutive angles are supplementary. All of them are parallelograms. Diagonals are congruent is only in rectangles and squares. Diagonals are perpendicular is only in rhombus and square. The diagonals bisect each other is all 4. Diagonals bisect opposite angles is only the last 2. Opposite angles are congruent is all 4 because they're all parallelograms. Opposite sides are congruent is all 4. And opposite sides are parallel is all 4. So notice these apply to everything. And then there's the more specifics that have to do with our rectangles from yesterday and the rhombus and the square from today. All right, that's the end of our study guide. Let's pause the video and go do the checkup.